So today's notes are from section 3.2 in your book. These are our first notes in Unit 3, other than the ones you took yesterday, which were also 3.2. The title is Measures of Variation, and the goal today is to be able to calculate the measures of variation. Variance, which we referenced in the opener, but that's a new term for today. Standard deviation and range. You've all demonstrated you know how to find the range, but that is also a measure of variation. The two most common measures of variation. The first one is the range, which is where you just subtract the lowest data point from the highest data point. There's pros and cons to any calculation for measure of center, measure of variation. In this case, the pros would be that it indicates that there's a difference in the heights of the members of the two data sets, and this is actually referencing an example that we'll do in just a little bit. The cons would be that it only utilizes two pieces of information, so it doesn't tell us much about the data set as a whole. The second most popular form of or measure of variation is the standard deviation. In fact, the sample standard deviation. It measures variation by indicating how far on average the observations are from the mean. Good. High standard deviation. So that's for a data set with a large amount of variation. The observations will be on average far from the mean. That should be in your notes from yesterday. Raise your hand if you have high standard deviation in your notes. Good. Low standard deviation, on the other hand, let's draw our little picture for high standard deviation. That's the bell curve that is spread out, and then the low standard deviation, that's where it's a steeper slope. For a data set with a small variation, the observations will on average be close to the mean. The pro here, the standard deviation, I'm going to abbreviate that standard deviation, is preferable to the range as a measure of variation because the standard deviation takes into account all of the observations, whereas the range considers only the largest and smallest ones. The con is that the standard deviation is not resistant to outliers. That should sound familiar. That was also one of the downfalls for the mean for measures of center. We had the mean, median, and the mode. The mean was the one that was not resistant to outliers. How to compute sample standard deviation. First, you calculate the mean, or X bar. Second, you subtract the mean from each data point, which, if you're making the chart, which is a great way to keep your information organized, it's X minus X bar. If we add the deviations from the mean, in our example on the back, we're going to get 0. And because that is not helpful, we square the deviations. Wow, I can't read. Cross out that next bullet point. That's left over. I worked these notes for you since yesterday's videos were brand new. So, doing a little differently. Step 3, square each difference from step 2. Be sure to use parentheses when squaring a negative. Step 4, the sample variance. Like I said, this is our new term. The symbol that we use for sample variance is S squared. And the way to do that is to just calculate the mean of the squares. That's when we add up column 3 and then divide by how many there are. For population standard deviation, sigma, from yesterday, a lot of you learned to draw a sigma. We divide the sum of the square deviations by n. N is the number of observations in the data set. You can add that in if you forget. We've seen n before in Unit 2. You simply divide by n. That's when you have data from the whole population, which is rare. Rarely do you actually have the opportunity to get data from every single person in the population that you're observing. So, more often, we're talking about the sample standard deviation. In this case, we divide the squared deviations by n minus 1. That's the focus of today. Why n minus 1? This is for the person that's really curious. Not all of us are that curious, but some of us are. And so, here's why we divided by n minus 1. One of the main uses of the standard deviation is to estimate the population variance. Right? Think about that inferential statistics. Division by n tends to overestimate, or sorry, it's underestimate. The population variance. And so we divide by n minus 1 in the sample variance, which tends to give the correct value for the population variance. Step 5. That's standard deviation. That's that final step where you just take the square root of the variance. You need to know the relationship between variance and standard deviation. Standard deviation is the square root of the variance. Flip it over. We're going to do one example together. If you already feel confident, you can go for it on your own. One key thing to note to find the sample standard deviation for team 1. For both teams, we will use row 2 from this picture of 2 basketball teams, 2 5-man basketball teams. Notice the first row is feet and inches. That's 2 units of measure. That doesn't usually work out very well. So we've got 72, 73, 76, 76, and 78. Right in column 1. Then we find x bar, which is 75. Add them all up, divide by how many there are. Anybody get something different? What do you get when you add these column 2 together? Zero. Good job. And then we square them. Again, you want to put those negatives in parentheses if you're using your calculator, especially. Add those all up, we get 24. Remember, s squared is when we take the total of column 3 and divide it by n minus 1. We have 5 players. Subtract 1. So our s squared, which is also our variance, is 6. And then our s, which is the square root of the variance, round to the nearest hundredth. What do we get? Because we're dividing by n minus 1. Since it's sample, thanks. And we can label with the same units that we started with. Since we squared and then we took the square root, we're back to the same units of measure. So there's your standard deviation. The formula, let's go ahead and write that out. S equals the square root. And you've seen this, you saw this yesterday in your notes. Capital sigma, which means the sum of x minus x bar squared. So the sum of all of the differences squared divided by n minus 1. That's the sample standard deviation. I'm going to have you work out question 2 in just a second, example 2, but I'm going to look at example 3 first. 3 standard deviations rule just says that almost all of the observations in your data set will lie within 3 standard deviations of the mean. We've talked about that, the 99.7% rule. So let's see what that visually looks like. You see the dot plot here, and then it's just got these vertical markings on it to indicate the different spots where we have the mean, and then 1 standard deviation above and below, and 2 standard deviations above and below, and 3 above and below. 50 is the mean, it's right in the middle. And then they just added 7.4 3 times. And then they subtracted 7.4 3 times. So we're going to set that up for this example that we just did. Let's just do for team 1. Cross that out and put team 1. So for team 1, x bar was 75, and s was, let's just round that to, would it round to 2.4 or 2.5? 2.5. Okay. We're going to round it to 2.5. We're going to draw that x-axis like we do with the dot plot. X bar 75 goes in the middle. And then we're going to do 1, 2, 3 above, and 1, 2, 3 below. And we can label those x bar plus s, x bar plus 2s, x bar plus 3s, we'll do x bar minus s, x bar minus 2s, x bar minus 3s. We'll go ahead and add it on. So 75 plus 2.5, that's 77.5. Plus 2.5 more, where would it be? Mental math, anyone? 80. We're doing 75 plus our standard deviation. Once and then twice, so that's 80. And then add 2.5 again. 82.5. All goes back to the mean. talking about everything's relationship to the mean. So 75 minus 2.5. So, good. 72.5 minus 2.5. Good. Good. So then let's put our points from that data set and see where they land within this. So looking back up at our first basketball player was 72 inches. How many? So he was 6 feet tall. 72 inches is right here, so put a dot there on our dot plot. And then 73, and then 76, 75, 77, 76 again, so another dot there, and 78. So you can see all of our data was within 1, 2 standard deviations of the mean. You can imagine if we sampled everyone on the entire team, they would be within 3 standard deviations of the mean. So that's our notes for today. Go ahead and try example 2 on your own. Make sure you're solid in calculating standard deviation.